here. This was the very first fundamental counting principle formula you were given. It says that if you can choose one item from m items and a second item from n items, then the number of two-item choices is m multiplied by n. And it does not only apply to two-item choices, you can extend it to three-item choices, four-item choices, five items, and so on. But this is a basic formula. Let me explain it a little bit more by doing an example. So look at this example. Suppose you go to a restaurant and the restaurant has four main dishes and two appetizers. And you're asked, how many two-item choices can you make of main dishes and appetizer? Or how many combination of two-item dishes can you order? Well then, simply put, that here we can correspond our four main dishes with m and the two appetizer with n, and then the amount of different combination of dishes you can order, it will be equal to 4 multiplied by 2, which give you 8 dishes. And they would all be different. All right, it's a combination of the main dishes and appetizer. So that is the kind of problem you will solve using this formula. We also have another formula here, this one here that I have on the board, which says that the number of ways in which a series of successive events can happen or selection can be made. You can, twist the formulas a little bit differently, is the product of the number of ways in which each selection can be made. So let's go ahead and explain that with an example. Here is an example. I'll read this out. It says that a person can order a new car in 4 different colors. In addition to that, the person has 4 options. One is that the person can choose a car with or without transmission, with or without power window, with or without CD player. Plus you have the color choices. So this is one where this definition would apply, where it says that the number of ways in which a series of successive events or selection can be made is the product of the number of ways in which each selection can be made. So in this example here then, we'll apply that definition here. We know we have 4 different colors. We have 2 choices for power window. We have 2 choices for CD. Alright, clear? And we also have 2 choices for automatic transmission. And we have 2 choices for automatic transmission. So then, what this is formally saying, the number of possible choices that you can make in purchasing a new car with all of these choices available to you is going to be 4 multiplied by 2, multiplied by 2, multiplied by 2, and this is going to give you 32 choices. All right? So that will give you 32 choices. So please take note of those definitions and the formula. All right? So any question, class? Any question on these 2 version of our fundamental counting principle? All right, and as I mentioned, this 2-item choices definition you are given here can be applied to 3-item choices, 4-item choices, and so on. It's not only limited to 2, but basically is the same principle applied. All right. Now let's go ahead and talk about permutation. Permutation is an arrangement where order is an arrangement of objects where ordering is very important. or selection of objects, and the order in which you select them is very important. Now, on the other hand, we have the term called combination. Combination is a selection of objects or ordering of objects where the order is not important. The way you select them, order is not important. So that is the difference between permutation and combination. All right? And there are two formulas for them. So let's say you have n items and you want to select r of them. And let's say you do not want to replace, or you cannot replace the item. Then the formula for that is going to be n factorial over n minus r factorial. So we have a permutation without repetition. We have permutation with repetition. We also have permutation with duplication. So all these are different forms of permutation, and we will use a special formula for these. So if you have n items and you want to choose r of them, let's say with replacement, you'll be using this formula here, n to the r power. So let's go ahead and do an example using this formula here. So let's say now, let me give you an example. If you are asked this question here, how many ways can you choose a two-digit number from the set of natural number less than 5? All right, you want to choose a two-digit numbers from the set of natural number less than 5. Now, this is a problem for you to solve. We want to choose a two-digit number from the set of natural numbers less than 5. So first of all, we have to figure out what those numbers are. But remember, it says natural, right? And we know that the natural number are the counting number. Remember, we talked about that, I think, some time ago. The natural number are the counting number, like you're counting your money and so on. So those numbers are going to be what? Anybody have an idea? What are the counting number for up to less than 5? Can we say 1 is there? 2 is in the set of that number. What about 3? And 4? Is that all right? It says less than 5. Anybody disagree with that? Everybody agree then? All right, so the set of counting number less than 5 are going to be 1, 2, 3, and 4. But here what the question is. It says, how many different ways can you choose a two-digit number from the set of natural number less than 5? Well then, we are going to be using this formula here, n to the r power. So our n is going to be our 4, the amount of numbers we have, and r will be the amount of number what we are choosing, 2, right? We are choosing 2 at a time. So then this is going to give us what? Right away, if we apply this formula, it's going to be 4 to the what? Second power. And this will give us how many? 4 multiplied by 4. And this is 16, right? Mm-hmm. So we have 16 two-digit numbers. You see how important this permutation comes into play? All right? We have 16 different two-digit number we can select. And if you will go ahead and you list those 16, that will be quite a little bit of an work for you to do. But you can do that. That would not be hard. If you list them, you know you can list 1 and 1, 1 and 2, 1 and 3, 1 and 4. All those are two-digit, right? Mm-hmm. Then we have 2 and 1, then to 1, 2 and 2, 2 and 3, 2 and 4, 24. So there you go, right there already we have 8, don't we? Mm-hmm. Of 2-digit number. So you continue the process, right? You have 3 and 1, 3 and 2, 3 and 3, 3 and 4. So how many we have there? We have 12. 12. We need 4 more. Yes. And then we can do 4 and 1, 4 and 2, 4 and 3, 4 and 4. So that gives us our 16. So you will be asked to do things like this. We have done it not only mathematically by using our formula, but you have went and you had and you list them and give a visual perspective of those 16, right? Mm-hmm. So you're fully convinced that that's it. Okay? All right. Now, there's a wealth of information in here with this kind of stuff. Now, we also have that permutation with duplication of items. And this is that definition here. This is what it says. It says that if you have n items and p of them are identical, q of them are identical, and r of them are identical, then the number of duplication, the number of permutation of those letters is going to be n factorial over p factorial times q factorial times r factorial. Now, you will ask, where does the n come from? The n is the amount of letters you have in the word. If you're using word, it doesn't only apply to words, but many other situations. But it's common. Like if you have the letters of a word or the amount of numbers you have and things like that, you can apply this formula if you have repetition of the letters and numbers or items or whatsoever you have. So let's do an example. Example, suppose you have the letter of the word Dallas, D-A-L-L-A-S. How many ways, this is what the question asks, how many ways can you arrange the letter of the words Dallas? Anybody have an idea?
You gotta count the different letters first.
Right, very good, very good. So, and that's going to give us our n, right?
Yes.
So that right? N is 6, right? Very good. So n is 6, then we'll look for our repetition now, right? Now we'll look for repetition. So we have our A repeat itself. So we'll say here that our P is equal to 2, right? And we have here the L repeats itself. You see that? We have 2L. So we can say our Q is also equal to 2. And we don't have any more repetition, right? So then we can put those into the formula, and this is going to give us 6 factorial over 2 factorial times 2 factorial, and this is going to give us 6 times 5 times 4 times 3 times 2 times 1 over 2 times 1, 2 times 1, and these 2 times 3 is 4, it takes off the 4, and if you multiply 6 times 5 we get 30, times 3 is 90, times 2 is 180, and you have 180 different ways to arrange the letter of the word Dallas. Alright? Well, that may come to you, okay, but say, wait, that's a lot of ways, right? But I mean, so I can't ask you to go and arrange them, because this is a lot of ways, it'll take up all of your time. But we can choose another example with a small amount of letters. Let's choose the word an, A-N-N. So let's do another example. How many ways can we arrange the letter of the word A-N-N, an, using the same formula? Anybody have an idea? What would our n be? What is our n? Remember here our n was 6, right? 1, 2, 3, 4, 5, 6. So n here is going to be 3, right? Because we have 3 letters. And our p is going to be what? 2, right? 2n. We have 2n. That's all we're concerned with. We don't have any more repetition. Or P, Q, and R here are our repetition of letters. And we only have one repetition n. So then this is going to give us here 3 factorial over 2 factorial. And this is going to be 3 times 2 times 1 over 2 times 1. This cancels out that. And that gives us 3 ways. Now, 3 ways we can arrange the letter of the word and. Now I'm going to ask you then to go ahead and show visually what those 3 ways are. And that's another little bit of exercise for you to do, right? So then you will see it's going to be A and N. That's the original, right? Then you might want to say N, A, N. That's one way, right? Because remember, these 2 N here are indistinguishable. But, and then you can say the other way is going to be N and A. 1, 2, 3 ways. Is there any other way? Everybody agree with that? So there is no other way, right? So that's what we mean by duplication. But it gets very large as the number of letters in the word increases. All right? Okay. So we have talked about fundamental content principle. We have talked about permutation. We talked about permutation without if you have n items and you want to choose r of them. And then we talk about if you have n items and you want to choose r of them at a time. Then we talk about permutation with duplication. We have permutation of items without replacement. Here's another one. Permutation without replacement. What this is, to find the number of ways you can make these choices, this is going to be n factorial. This is another formula. So if you have n items and you want to choose all n, all of them, this is the number of ways you can arrange them is going to be n factorial. Let's do an example. Suppose you have 4 books. Let's say you have 4. Example, you have 4 books. And you want to place them on the shelf. How many ways can you place these 4 books on the shelf? Alright, so then we have a formula say here, it's going to be n factorial. Why? Because we want to place all of them. We are not choosing a certain amount of them, or part of them, we are choosing all of them. So this here, and without replacement, we are not replacing any of them. When we choose one of them, the amount that we have is going to be reduced by that one. So then, you have 4 books. The number of ways of choosing from the 4, to make the first choice is going to be how many ways? We have 4 ways, right? Then when we choose one, how many books do we have remaining? 3, right? Then we'll have 3 ways to choose there. Then when we choose the second book, we'll have 2 remaining, right? So then we'll have 2 ways to choose there. And then when we choose another one, we'll only have 1 book remaining to put on the shelf. And the number of ways is going to be 1. So the number of ways to place 4 books on the shelf without replacement is going to be 4 multiplied by 3 multiplied by 2 multiplied by 1. So this is an example. N equal to 4. So this is going to give us 4 times 3 is 12, 12 times 2 is 24. So 24 ways you will have to select 4 books and place them on the shelf without replacement. Alright? Now, this should take care of permutation. Let's go ahead and talk a little bit about combination. We have said that combination is a selection of objects or arrangement of objects where the order of arranging them or selecting them is not important. And the formula for for solving those kind of problem is n factorial over n minus r factorial times r factorial. So let's go ahead and solve a problem using this here. Now let's say you have 4 marble, and you want to choose 2 of them at a time. Now the order of choosing 2 marbles is now important. How many ways can you do this? How many possible choices do you have? So this is a problem here. Example, you have 4 marbles. How many ways to choose 2 of them? 2 from the 4. Order is not important. Order of choosing is not important. Let's say the marbles are red, blue, green, and yellow. Let's say you have a different color of marble. Now, I'm doing that just to make some distinction. The way of doing that then, by using the formula, our n is going to be equal to 4, r is equal to 2, so it will be 4 factorial over 4 minus 2 factorial times 2 factorial, which is equal to 4 factorial over 2 factorial times 2 factorial, 4 times 3 times 2 times 1, 2 times 1, 2 times 1. This 2 times 2 cancel out at 4, and you have 3 to 6 times 1 is 6 ways. You have 6 possible choices, or 6 ways of doing that. And if you're asked to list the ways, then you can go ahead and list them. Since I said that the marble, let's assume that they are red, blue, green, and yellow. R, B, G, and Y. So the 6 possible choices are going to be red and blue, red and green, red and yellow. All right, so we have all of those. Then we have blue and green, blue and yellow, and we have green and yellow. So all of these here, these are our 6 choices. 1, 2, 3, 4, 5, 6. All right. Order of choosing them is not important. You can choose a red and a blue, or a blue and then a red would be the same. Now, that same problem would be a nice one to work using this formula for permutation, where ordering is very important. And if you do that, you'll get a different outcome. Why would we get a different outcome? Because here, ordering is very important. Everybody see that? Any question? Somebody must have some questions. So I'm assuming that everybody comfortable. Yeah.
Could you, instead of marking off the 4, could you do the 2 and the 1 and 2 and the 1, just leave 2 and 1 on the bottom for the Dallas one?
Oh, this one is Dallas?
Well, the one over there. The one to the right. Instead of eliminating 4, could you do just eliminate 2 and 1, just leave the 2 and 1 on the bottom too?
Oh yeah. Oh yeah. You're saying that instead of eliminating the 4,
yeah,
we could have taken all this 2 and 1 here, and then take that off.
Yes.
Right, and then this 2 will go into that 2 times. Okay. Yeah, then this 2 here will go into this 4 2 times. So then what we have then is going to be 6 times 5 is 30. 30 times 2 is 60. Right? 60 times 3 gives us 180.
Okay.
All right, very good. That's a very good question. You can cancel it anyhow you want.
Mm-hmm.
Okay, because as long as we get them reduced, it doesn't matter how we reduce it. And it's a very good question. All right? Thank you very much for asking that.
You're welcome.
All right? So So anything else concerning this? I know our time is moving, and you need to solve those problems, but I want to make sure that these definition formulas, these concepts are well taken and they are explicitly understood, especially the differences between permutation and combination, because there is a difference there, and you don't want, and in solving the problem, you have to know whether the problem asks for ordering of the items or whether ordering of the items are not important. That is a key element in solving the problem and applying the correct formula. Because if the problem is a permutation problem and you use combination formula, then you are going to be getting the wrong answer. All right? And vice versa. If it's a combination problem and you use permutation formula, then you are going to get it incorrect, right? So that's why we spend a little bit more time today in distinguishing between permutation and combination. And you see that in permutation we also have some variation. Permutation with repetition or replacement, without replacement, permutation with duplication, and so on. So I'm taking it that you all understand that, and then we are going on to probability using this concept on Friday. We'll be doing probability in depth.
So Wednesday will be the test for?
That will be next week.
Next week.
Yeah, that test will be on next week. But we have this Friday and probably 1 or 2 sessions next week to cover these important topics. All right? Very good.